All right, guys, today kind of a fun one. We are on, 5.5, and we're talking about slope fields. So what a slope field is it's kind of, it looks like a graph, it looks like a diagram, and it's showing you what the slopes look like at different points on the original function, okay? So you've seen these already. We've looked at slope fields a little bit. But what we're going to do to start with is we are going to draw a slope field. And in order to do that, over here on the left, number 1 says that dy dx, my slope, is equal to x plus 1. All right, so my slope is equal to x plus 1. It doesn't tell me what x is or what y is. It just tells me my slope. So what I'm going to do is I'm going to plug numbers in for x and y and get values for my slope. So I'm going to get numbers for, I'm going to make a little table right here, and I'm going to x's, y's, and at those points, I want to know what my slope is, okay? Now, if you notice, it doesn't give me specific x's and y's. I get a pick. So for example, I can say, well, at 0, 0, this point right here, what is my slope? Well, when x is 0, my function that I'm using, 0 plus 1 is 1. There's no y value, so I don't have to plug in y equals 0 anywhere, but my slope is 1. So at that point, at 0, 0, I have a slope of 1, and I draw this little dashed line, okay? Then I pick another point. How about 0, 1? So when I plug in 0 and 1, 0 plus 1 is still 1. Because my y value doesn't change it because there isn't even a y value. So at 0, 1, my slope is still 1. At 0, 2, when I plug in 0 and 2, my slope is still 1. And if you haven't noticed the pattern here yet, even if I plug in 0, negative 1, I'm still going to get a slope of 1. 0, negative 2, I'm going to get a slope of 1. So since my y value, there is no y value to plug in, it doesn't matter where I'm at with my y values. My answer is always going to be the same. So let's pick a different x. So let's look at this point right here. Let's go when x is 1 and let's say y is 0. So when I plug that in, x is 1, 1 plus 1 is 2. So my slope right there is 2. So it's going to look a little bit more like this. At 1, 1, at this point, my slope is also 2. At 1, 2, my slope is also 2. Now, when I'm drawing this, I need to be really careful. If you're doing this on the AP test, your slopes, these little dashed lines cannot touch. Okay, we got to be careful that they don't actually touch each other. We need to draw the line big enough that you can tell the slope of the line because it represents the slope, but we can't actually have them be touching each other, okay? So if I keep doing this, if you notice the pattern, my x's change, but my y's, it doesn't matter my y value, it stays the same. So let's just skip ahead. And let's say when x is 2, then my slope becomes 3. So my slope gets steeper, but it stays the same all the way here. When x is 3, my slope becomes 4. So I get even steeper. All right? Well, let's go the other way. What about when x is, and I'm running out of room here, so I'm going to make another table, x, y, dy, dx. How about when x is negative 1? It doesn't matter what my y value is because there's no y value to plug into. When x is negative 1, then my slope is 0. So right here, whenever x is negative 1, my slope is 0. So I draw little flat lines. How about when x is negative 2? Well, negative 2 plus 1 is negative 1. So my slope is, let's start right here. These ones are a little bit easier to draw first because I can use my other dots to. So my slope is negative 1. When x is negative 3, my slope is going to be negative 2. All right? So again, these ones are a little bit easier to draw. So that basically what I'm getting is I'm getting a general shape of these are what the slopes look like at these points. Now, my graph, I don't know where my graph is, my original function, but I know the slope of my original function. I know that when I'm at -1, when my x is -1, my slope is 0. My graph is flat. So I would expect my shape to look something like a parabola. If I look at my slope field, it doesn't matter where I'm shifted up. Whoops, that was not accurate. It doesn't matter where I'm at, but my slope, the shape of my graph is going to be some sort of parabola. Wherever it's at, it's going to be a parabola, okay? Let's go ahead and solve this one because it asked me to solve the differential equation as well. So if I were to solve this really quick, I would say dy equals x plus 1 dx. So if I integrate both sides, then on this side I end up with y equals what? 1/2 x squared plus x plus c. Well, doesn't that look like, isn't that a parabola right there? Which is what I expected it to be. So that tells me my original function is a parabola, which kind of matches my slope field, all right? So number 2, if you look at this one, when I make my table, my x, y, and my dy dx table, notice that this time I only have y values. So it doesn't matter what my x is, it's always going to be the same. The only thing that changes it is when I change my y. Okay, so let's start right at 0, 0 again. Let's say 0, 0. Well, 0, 0, when I plug a 0 in for y, my slope becomes 0. So whenever y is 0, my slope is 0. So I've got a line here, a line here, a line here, a line here, 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 here. Whenever y is 0, my slope is 0. Okay? I'm not going to do a whole bunch of different x's because it doesn't matter what my x is. It only matters what my y is. So what happens when y is 1? 1 times 2 is 2. So when y is 1, anytime y is 1, my slope is 2. So to do that one, let's see. Let's go, we're right about here, right? So anytime my y value is 1, my slope is 2. Anytime my y is 2, my slope becomes 4. Wow, that's getting big really quick, right? So anytime my y value is 2, my slope is 4. So now let's look at, well, what happens when y is a -1? When y is -1, my slope becomes -2. So instead of +2, I'm looking at -2. So my slope is coming down. And whenever y is -2, my slope is going to be -4. So my slope gets steeper as it goes down and steeper as it goes up. So if I'm trying to think about what it looks like my graph, the top part of my graph is kind of going up like this. The bottom part of my graph is going down. And they're both flattening out as we get closer and closer to when my y value is 0. All right, so let's do the differential. If I solve this differential equation right here, so I've got, let's leave no, we better move it over there. So 1 over y equals 2 dx. Unless we want to bring the y, let's bring the 2 with it. Let's rewrite that. 1 over 2y equals dx. So when I take my integral, so that's like 1/2 integral of 1 over y equals the integral of dx. And how come I forgot my dy? Can't forget my dy. There's a dy over here, guys. Don't get lazy. 1 over y, the integral of 1 over y is natural log. So 1/2 the natural log of y is equal to what? X plus c is all. So that means that y, if I times by 2, then the natural log of y equals 2x plus c. And then if I take e of both sides, then y equals, the absolute value of y equals e raised to the 2x plus c, okay? Which becomes y equals c e to the 2x. All right. And y equals negative c e to the 2x. Because I get both of them, right? My graph, I get the up and the positives and the negatives. And that, I mean, if I were to graph that, if I were to graph this right here on my calculator, so let's take a look at that. Let's go y equals, and we're going to do, I don't even remember what it was, some constant, so let's just say 5, e raised to the 2x, okay? And let's say negative 5 e raised to the 2x. So when I graph that, look at my graph. It looks just like what we thought. Now, we don't know what c is. So we don't know, like, watch what happens if I change my c. If I change this to negative 1, and if I change this to, whoops, come on, nope, down, over. If I delete that one, notice that it changes my graph. It's going to shift my graph. I don't know what my c values are. All I know is the general shape of the graph, but without those initial conditions, I don't know exactly where it starts, okay? All right, but we know the general shape of it. So, match each slope field with the equation that the slope field could represent. All right, so it gives me a bunch of slope fields, and it wants to know which equation it goes with. All right, so as I look through these at the bottom, let's start with some easy ones. C kind of looks like a parabola. So if I go down here, right there, 9 kind of looks like a parabola. So that's probably C. B and E, look at these two. B and E kind of look like sine cosine waves. And E starts going up and then down. B starts going down, which means that E is probably my cosine. And B would be my sine graph. So what do we have? We said this is 13, this is 12, we think this one is 9. Look at H. H is just a straight line. There's a straight line right there for you. Y equals X, they're the same, right? The slope is always 1. And then you have some others that get a little bit funky. Oh, not D. D's just a straight line, which means that there is, and remember back up here, when our x's, when going left and right, it always looked the same. That means there was only a y. There was no x in it. So if I look down here, which one only has a y value? Right here, number 7. That straight line. That's number 7. And then I've got a little bit of work to do. 1 over x squared. I've got 1/6 x cubed. Well, x cubed, these are usually what our x cubed ones look like, right? They usually have that, almost that tangent shape. And then we've got natural log. What is left? 1 over x squared and the natural log. Is that the only ones that are left? Okay. Now, one of them, if you look at the general shape, one of them never, as I move to the right, I flatten out. And same with the other one. The difference is, our direction, right? Our slopes. On G, our slopes are positive as my x's are positive. So if I look at these two functions right here, I've got 1 over x squared and natural log of x. So if I put in a positive number, so 1 over x squared, if I put in a positive number, I'm going to get a positive slope, right? If I put in a positive number, I'm going to get like 1 over 4 or 1 over 9. If I put in a negative number, I'm also going to get 1 over 4 and 1 over 9. So it doesn't matter what my x value is, my slope is going to stay positive, and which that makes me think that we got one wrong, right? Because where does my slope always stay positive? That's this one right here. Hey, we messed up. F is going to be our 1 over x squared. F is going to be our 11 because our slope always stays positive. This one right here, our slope does not, and either does our natural log. So these two we're going to have to decide between 10 and 14, and this one as well, 10 and 14. And if you're not sure, you can keep plugging in numbers and seeing what happens. One of the, you can plug in whatever number you want. So for like number 10, I can plug in x and y being 1 and see what I would get. So when x is 1, right here, I get 1 over 6. So y would be 1 over 6. Over here, when x is 1, then I'm getting the natural log of 1. So you can plug in numbers and use that to try and help you figure out what's going on. Or you can graph the picture and look at what happens there. So if you want to go here, I can say y equals, and if I wanted to say 1/6, and then what was one of them? X cubed, I think that said x cubed. I can't tell what that number is. That doesn't even look like a real number. That makes it a little bit harder there, doesn't it? So let's plug in the natural log. If we look at our natural log function, natural log of x, and graph it, then our slope is going up instead of down when we start, which looks more like this one right here. This looks more like a natural log, which leaves us with this one, A, to be our whatever this nonsense is that I can't read. So anyway, a couple of different ways to solve those. This one's a little bit different because it wants us to match the slope field with the differential equation. So it's giving me the equation of the slope, and it wants me to match my slope field. So there's a couple of things I look for. First of all, as I look at these, I want to know, does it stay the same when I go up and down or left and right? Okay, so if I look at B, as I go up and down, as my y value changes, my slope stays the same. So that means there's probably not a y in it. Okay, well, maybe it's changing just a little bit. No, it's not changing. So as I'm going up and down, my y's not changing at all. This one, as I go left and right, my slope isn't changing at all. So that means this one's not going to have an x in it. Right? Because as I go to the left and the right, it looks like it's staying relatively the same. It doesn't look like my function is changing. So when I look over here at my options, number 15, there is no y. So 15 is probably going to be this one right here. There is no y value. And then number 16, there's no x. So this one is probably going to be number 16. All right. And then I'm left with A and C. And both of them change. As I go up and down and left and right, the slopes are changing. So I have a couple of options. The easiest way to do this is to just check, because it gives me my slope function, I can just check points. So for example, let's plug in something, let's pick a point. So on my A graph, if I go over 1, up 1. So if I go right here to 1, 1 on both of these graphs, on this graph right here, it tells me that my slope is going to be 0. I'll have no slope. This one tells me that my slope is what? Going to be -1, it looks like. So when I plug those in down here, on 17, when I plug in 0, 0, I get 0 minus 0, which is 0. On this one, or not 0, sorry, I'm plugging in 1. Sorry. When I put 1 minus 1, I get 0. When I put -1 over 1, I get -1. So that means that 18 at 1, 1 has a slope of -1. So this is going to be my 18 equation. And 17 at 1, 1 has a slope of 0. So this is going to be number 17. So you just pick points, plug it in, and see which equation the slope matches. And be careful what you pick. If I had picked 0, 0, I didn't do that on purpose because look at 0, 0, my slope doesn't look like it exists or it looks like it's 0. So that one might be kind of hard to tell the difference between because my slopes are the same. Look at this point right here. If I were to go to -1, my slopes look pretty similar. So that might not be a good number to pick. Same with -2, -1. Those slopes look the same. So that might not help you separate which one is which, all right? Okay, 19. The calculator drawn slope field for the diffie q dy over dx equals xy is shown. So it gives me a slope field, and then it says the solution curve passing through the point 0, 1 is shown. Sketch the solution curve through point 0, 2. Okay, so 0, 1 is right here. And from there, if I follow the slopes, it gives me this graph. Now, if I want to go through 0, 2, then that means I'm going to be starting right here. And from right there, from that point, my graph is going to look something like this, okay? At 0, -1, that's right here. So as I go left and right, I've got to follow that slope. So this one's going to go like this. You kind of have to follow the slope fields, all right? You can't be crossing through the lines. So look at this one here. Sketch the solution through 0, 1. Okay, so if I start right here, whoa, easy, easy, easy. If I start right here at 0, 1, then as I go to the right, I'm going up like this. And as I go to the left, look what happens. Right here I go flat, and then I start following this line right here. It looks like there might be an asymptote as I reach that point right there, okay? It's important, though, that you don't cross those lines. So -3, 0. So if I go over 1, 2, 3, this is my starting point. And then I need to follow the slopes without crossing those lines, right? So I'm going to curve this way, and this one's going to curve down really quick. Okay, and maybe that top part might not have been, I might need to be a little bit more careful as I go up, right? This one might have gone up right here. So you just start at that point, and then you follow the slopes as you go left and right. Are those the only two that it gave us? So if I were to, let's do one more. Let's say I started right here. Then as I go to the right, I've got to follow this slope up. And as I go to the left, I've got to follow this slope down. Okay? So eventually they're going to all look really similar, right? I mean, if I started just one spot over, my my diagram is going to look almost the same. It's just shifted a little bit. If I start 1 point over, then they're going to look almost the same. They're just shifted a little bit. So, and then as I go further to the right, then it's going to go up here, and this one's going to come down. And so they almost look the same. They're just, and see, that one's probably, when I came down, I probably should have gone underneath here like this. So as long as you follow those slope curves, then you're okay.